This video is to help you facilitate lessons 50, 51, and 52 of the 6th grade Excel curriculum. This set of lessons focuses on work within the coordinate plane. In lesson 50, students are going to need graph paper, and they are going to do some problem solving using the coordinate plane, specifically finding the distance between 2 points. In this first example, students are given a coordinate plane, and they are told that the school is located at the point 2, 4, and the library is located at the point 2, -3. We need to know this. If each unit on the plane represents one block, how far does Kyle have to walk to go to the library after school? So our first step is to plot the points, which has been done on this example for you. And then we're going to use absolute value to find the distance. We want to define absolute value for students. We don't want to tell them that absolute value means the number's positive. You want to help them understand the true definition, which is a number's distance from 0. And because distance can't be negative, like we never travel -5 miles, so distance is positive, that means that our answer is always positive. So after we plot those 2 points, the first number in the pairs are both 2. So because those the first numbers are the same, we're going to use the second number, the y-coordinate, to find the distance. So we first have to find the absolute value. We find the absolute value of 4, which is 4, and the absolute value of -3, which is 3. Tell kids when we see those 2 lines that means absolute value. That's the symbol. And then we add those 2 absolute values, and that's how we get 7 blocks. Students can also count. They can count the vertical distance between the school and the library. They'll also get 7. When they jump into the second example, again, each unit on this plane represents a mile. The ordered pair for Luke's house is 4, -3. Leah's house is west of Luke's house, and Luke and Leah live 9 miles from each other. We need to find the ordered pair for Leah's house. So first we're going to plot Luke's house, which is done. And then we need to figure out where Leah lives. And so we're going west. It would be helpful to help students understand their directions here by labeling. So this is north, this is south, to my right is east, to the left is west. So we're going to the west. That's how we can identify where Leah lives. And since she lives 9 units, we're going to count 9 units away from her house, 9 units west, and we end up with the point 5, -3. We can use the strategy that we just learned in the first example to calculate the distance between the 2 coordinates, the numbers that are different, which is 4 and -3, to see if we get 9, and you do indeed do. So students are going to use those strategies as they jump into the practice problems. They are going to need to use their graph paper for these practice problems. It's going to be really helpful. As you jump into lesson 52, then 51 the next day, students are still working with the coordinate plane, but now they're plotting ordered pairs, and they're going to have to describe where they are on the coordinate plane. So in this first example, we are plotting for -3, and we have to identify what quadrant it's in. Before doing any work, we need to orient students to the coordinate plane. So reminding students that the coordinate plane is made up of 2 perpendicular lines. The horizontal line is the x-axis, the vertical line is the y-axis. The point in which they intersect is the origin. So 0, 0 is the origin. And the axes, so the x-axis and the y-axis, divide this coordinate plane into 4 quadrants. And the way the quadrants are numbered is important. So the quadrant in the upper right-hand corner is the first quadrant, and then we count counterclockwise. So this is 1, 2, 3, 4. They are always labeled the same. So those labels never change. So now we can start the work. We can plot 4, -3, which we see here. So we start with the origin. And remember, this is our x and our y. So we're going to go over to -4 and come up to 3. So this is how we get where that point is located. So they're going to come over to -4, up to 3. That's how they're able to plot the point. And now they need to identify the quadrants. Students should label 1, 2, 3, and 4. And then it's very easy to see that -4 and 3 is in the second quadrant. Students can also use signs, so you can show them here that we can look at the signs of coordinates to figure out where the ordered pairs are. Coordinates in the first quadrant are always going to be positive, positive. In the second quadrant, the x-coordinate will always be negative, the y-coordinate will always be positive. In the third quadrant, both coordinates are going to be negative. And in the fourth quadrant, the x-coordinate is positive and the y-coordinate is negative. So we can use either strategy for the triad when we plot 2, -2. We can plot it on the coordinate plane. We see very easily that it's in the fourth quadrant. Or we can see that the x-coordinate is positive and the y-coordinate is negative, also telling us it's in the fourth quadrant. We're going to use the same strategy to jump into example B, where we're plotting points. We're identifying the quadrants. And it's just as simple. They can either use what they learned in the first example about how you describe the numbers, or they can actually plot the points. It's going to be helpful if students practice plotting the points, and they will use that as they practice. When they jump into the practice problem, students can plot all points on this coordinate grid. If students struggle, it might be helpful to give them an extra piece of scratch paper. Jumping into the final lesson of the week, it's a continuation. 52 is a continuation of 51. We're continuing to plot ordered pairs on the coordinate plane. It will be helpful for students to have graph paper for this lesson. So we jump into example C. And it tells us from Zoe's house, the hospital is 2 blocks east and 4 blocks south. So we're talking about the hospital here. Her school is 3.5 blocks to the west and 1 block south. The park is 2.5 blocks to the west and 2.5 blocks north. The library is 4 blocks to the east and a half block north. Students need to plot all of those locations in relation to Zoe's house. So the first thing we need to do is write an ordered pair for each one of those. Zoe's house is where we start. And on the coordinate plane, the place where we start is the origin, which is 0, 0. So Zoe, we don't want to forget that, is 0, 0. When we're talking about the hospital, it says that it's 2 blocks to the east. So if I'm starting at Zoe's house and I'm going east, that means I'm going to the right, which is positive. And 4 blocks south, that means I'm going down, that makes it negative. When I'm thinking about the school, and I'm starting at Zoe's house, so I'm starting at 0, 0, it's 3.5 blocks to the west. To the west means I'm going in the negative direction. So that's negative 3.5. And then it's 2.5 blocks north. Sorry, her school is 1 block south. South is negative. Forgive me. The park, this is why it's going to be important to do this with students. The park is 2.5 blocks west. So that's going in the negative direction. So that's negative 2.5. And 2.5 blocks north. So that's going to be positive 2.5. And then the library, we're always starting at Zoe's house, is 4 blocks to the east. So I'm going towards the positive. And a half block north. So I'm going up. So that's positive 1/2. Students then need to plot those points on the coordinate grid. Then they're going to use that to identify where the grocery store is located. So it's going to be important that you help students write the coordinate planes, coordinate points for each of the areas in the neighborhood. Don't just give this to them. Help them understand how we get those coordinate points. Then we jump into example D. Example D, you want to take your time and help students through this question. So we want to reflect the triangle ABCD across the y-axis. So you first want to ask students, what does a reflection mean? Have them think about when they look in the mirror. When you look in a mirror, what do you see? You see yourself. I see myself facing in a different direction. I'm not taller, I'm not shorter, I'm not larger, I'm not skinnier. I see me in the same position facing a different direction. So when I reflect the shape, it's going to be in the same position, but in a different direction. So when I'm reflecting this across the y-axis, you also want to make sure that students know if I'm reflecting across the y, this shape is going to end up over here. If I was reflecting across the x, that is when it would end up there. But we're not going across the x, we're only going across the y. And because we know it's going to end up in the same space, you want to ask students, look at the coordinates for A. A is at -5 and 2. So if I'm going to end up over here, and this rectangle is not going to get any smaller or any larger, where is point A going to end up? It must end up at the 5. 5 and -2. B doesn't get any larger, any smaller, and I'm at 2, -3. -2, I'm sorry, -3 and -2. Then I must be ending up at 3 and -2. So that my rectangle stays the same size. That is going to help students as they plot the points for C and D as well. Now it's going to be easy for them to write the ordered pairs for A prime, B prime, C prime, and D prime. And then you can have a discussion about how the coordinates change when they're reflected across the x-axis. So for this problem, you really want to take your time and make sure students know how they're getting from one side of the axis to the other. And that is going to help them as they jump into the 4 practice problems for the day. And you want to pay attention in one, make sure they know which axis, particularly when you look at 19 and 20, they know which axis they're reflecting across and how they can determine where their points are located.